Hi, I'm the Amateur Logician, and in this video we're going to work through another problem from discrete mathematics dealing with propositional logic. Here we're given this proposition, which of course overall is a conditional, and our goal is to prove that that proposition in fact is a tautology. In other words, it is always true, and we're going to resort to such laws as the negation law, perhaps the absorption law, but also the identity law and the domination law. And your average discrete math textbook describes these laws. Generally speaking, the strategy has to be, when working with problems like this, to gather like terms, to get the p's together, to get the q's together, to get the r's together, because then hopefully we can then resort to the negation law. Because if we can get something of the form p or not p, we have something that is necessarily true by the law of excluded middle. Conversely, if we get something of the form p and not p, we have something that is necessarily false because of the law of contradiction. But then, if we get something that, hey, this is necessarily true or this is necessarily false, we can then resort to the identity law. And finally, in terms of our very last line of inference in our derivation, we should be able to use the domination law and say, hey, this in fact is a tautology, or conversely, this is just a contradiction. So here we have our given proposition. It is a conditional, and it's a good idea to transform it into a disjunction. And we can do that in propositional logic because if P then Q, in fact, is logically equivalent to not P or Q. And notice, it is, of course, a very good idea to transform it into a disjunction because, look, the negation law, the absorption law, the identity law, the domination law, those all deal with disjunctions or conjunctions. All right, so let's take our given proposition and transform it into a disjunction. So for line 2, we're going to deny that antecedent and put it in a disjunctive relation with the consequent. So not, bracket, parentheses, P arrow Q, close parentheses, and parentheses, Q arrow R, close parentheses, close brackets. So we deny the antecedent, and then we'll put in a disjunctive relationship with the consequent. So or, parentheses, P arrow R. And that's just a logical equivalency. And some textbooks call that particular logical equivalency an implication. Now I think I'm going to abbreviate most things from here out. But anyways, so we got line 2. And notice here we have a conjunction. It's being denied. Hence we could apply De Morgan's rule. So for line 3, let's do that. So bracket, not, parentheses, P arrow Q, close parentheses. So we're moving from a conjunction to a disjunction based on De Morgan. So or, not, parentheses, Q arrow R, close parentheses, close brackets. Or, parentheses, P arrow R, and that is based on De Morgan. We have a conditional here, we have a conditional here, we have a conditional here. So let's make use of that logical equivalency, that so-called implication. Thus, for line 4, we'll get the following. So if P, then Q, we'll get not P or Q. And likewise, for if Q, then R, we'll get not Q or R. And for P arrow R, we'll get not P or R. And that is just our logical equivalency, our implication. We can use De Morgan again. Here's a disjunction. It's being denied. Here's a disjunction. It's being denied. Thus, for line 5, we'll get the following. Bracket, parentheses, not P and not Q. That's just based on De Morgan. Or, parentheses, not Q and not R, close parentheses, close brackets. Or, parentheses, not P or R, close parentheses, based on De Morgan. We can clean this up because we have these double negations. Hence, for line 6, we'll get the following. So from not P just to P. From not Q just to Q. I suppose we'll just say that's a logical equivalency, but remember, of course, that's just double negation. Well, De Morgan is also a logical equivalency, but at any rate. All right. Now we want to gather up like terms. So here's a P, here's a not P. They're very far apart. But don't forget, we have the commutative rule. We also have the associative rule. Now, I remember when I was first learning this, for the first time, a lot of times I forgot about the associative rule. And when you have a very long, complicated-looking molecular sentence like we do now, it's easy to forget the associative rule. So always keep those things in the back of your mind. We have the associative rule. We have the commutative rule. So let's use the commutative rule. And for 7, we'll get this. So parentheses, not P or R. So just wanted to move that because I want the P's closer together. So or, bracket, parentheses, P and not Q, close parentheses, or parentheses, Q and not R, close parentheses, close brackets. And that is the commutative rule. Great. But we also have the associative rule. Notice this is a disjunction. This is a disjunction. We can move around those brackets because, after all, we want the P's closer together. So for 8, we can say bracket, parentheses, not P or R, close parentheses, or parentheses, P and not Q, close parentheses, close brackets, or parentheses, Q and not R. And that's just the associative rule. Now, actually, I'm going to, because I think this is going to be a little bit easier, I'm going to take this expression, just flip them. And, of course, we can do that with the commutative rule. So for 9, we get bracket, parentheses, P and not Q, close parentheses, or parentheses, not P or R, close parentheses, close brackets, or parentheses, Q and not R, close parentheses, commutative. And for 10, I want to do another reassociation here. Because, in fact, I wanted here to be a disjunction, here to be a disjunction, and here to be a disjunction. Because I want to group these guys right here. So for 10, I'm going to say bracket, parentheses, P and not Q, close parentheses, or not P, close brackets, or brackets, R, or parentheses, Q and not R, close parentheses, close brackets, the associative rule. Great. We also have another rule, the distribution rule. Because here we have this conjunction, and here we have this disjunction. We can distribute. Likewise, we have this disjunction, this conjunction. So for 11, we can get the following. So bracket, parentheses, P or not P. Now they're very close, just where we want them. And parentheses, not Q or not P. Close parentheses, close brackets. Or brackets, parentheses, R or Q, close parentheses, and parentheses, R or not R. Close parentheses, close brackets. And that is by distribution. But notice, here we have P or not P. Here we have R or not R. By the law of excluded middle, those are necessarily true. So we have the so-called negation law. Thus, for 12, we can get bracket, something that's necessarily true, and parentheses, not Q or not P, close parentheses, close brackets, or brackets, parentheses, R or Q, close parentheses, and something that is necessarily true, and that is by the so-called negation law. Great. But if you think about it, so here we have this conjunction. We have something that's necessarily true in it, So the truth or otherwise of the conjunction as a whole is entirely dependent upon this disjunction. That is to say, on the truth value of that disjunction. And likewise, we have this conjunction. We have something that is necessarily true. So the truth value of the conjunction as a whole is entirely dependent upon this disjunction. And that is just the identity law. So for 13, we'll get parentheses, not Q or not P, close parentheses, or parentheses, R or Q, close parentheses. Identity law. For 14, let's get things closer together. Here's this not Q, here's this Q. Let's get them closer together. Hence for 14, we can get parentheses, R or Q, close parentheses, or parentheses, not Q or not P, close parentheses, commutative rule. Notice, here's a disjunction, here's a disjunction, here's a disjunction. We can move around those parentheses really straightforwardly. Thus, for 15, let's get R or parentheses, Q or not Q, close parentheses, or not P, by the associative rule. But look here, we have this Q or not Q by the law of excluded middle. That's necessarily true. That's the so-called negation law. So for 16, we can get R or something that is necessarily true or not P by the negation law. But here we have this big disjunction. This option is necessarily true. So regardless of the truth or otherwise of R or not P, this disjunction is going to be true. And thus for 17, it is definitely the case that we have a tautology by the domination law. And so we have proved, step by step, that our initial proposition, in fact, is a tautology resorting to the negation law, the identity law, and the domination law. I hope this video has been somewhat helpful. Thank you so much.